Hi, everybody. Hope you guys are doing well. It's Tuesday for you guys. I hope you had a great weekend, and I hope all is well. So just continue to kind of keep doing what you're doing. This week I only see you Tuesday, Wednesday, and Thursday, so we're gonna hopefully get through Unit 4 and move into Unit 6. And then we'll continue with that next week. And again, each day you'll have a short review video from me and just some working on the FRQs. And again, FRQs are just like riding a bike. You need to keep practicing, you need to keep writing. It really doesn't benefit you to look up the meanings or look up College Board rubrics just to get the assignment done. That's not going to help you on the day of the test. Really, it's just getting things in your own word, collecting your thoughts in your own words, and applying those terms and concepts to the FRQ. I mean, that practice, repetition over and over is really going to help you for the day of the test. Okay. Again, don't hesitate to reach out if you have questions. If you want to Google chat, it's been nice to chat with some of you guys on Google Chat. I miss you all. I'd love to hear where you guys are all going to college. A few of you have been emailing me, so it's been fun to catch up and hear about you from that. Okay, so we're going to jump right into Unit 4 review. Remember, this is the sensation and perception unit, and a lot of anatomy on the ear and the eye, so the auditory and the vision process. Okay, so we're going to start with sensation and perception and just trying to figure out, what this is and how it relates to psychology. And it's basically, just your brain's way of understanding all of these different senses and these visual and auditory cues, and it just sends it to the brain to process it. So remember, the difference between sensation is it's gathering all that new data, like what's this smell, what's this taste, what's this, vision, and then it makes sense of it through perception, which is the process of that information into new data. Okay, and I always bring up bottom-up processing and top-down processing. That's usually always on the AP exam. But bottom-up processing, that's where sensation happens. So it's like making sense. It's your brain. Those things are coming into your brain, and it makes sense of that new information. And then top-down processing, that uses our experiences and our expectations and that higher order thinking, and then to make sense of it. So remember, my example in class was, think about your freshman year at MC. If you've never experienced high school and you were coming in for the first time, you're using all of those senses and that bottom-up processing to figure out, where's my locker? Where's the lunchroom? Where are my classes? Where's this? So that's bottom-up processing. You're making sense of new information. Where top-down processing is when you came in senior year, you guys knew this is your senior hallway. You know where the cafeteria is. You know where all the classrooms are. You know the teachers. So you're using your experiences and expectations and then that higher order thinking, to process information. So we mostly live in a world where we're using our top-down processing because we're using our experiences. And I stuck transduction in here again because just transduction is it's that process of taking raw materials and turning it into perceptual information. And we'll bring it up again as we talk about the anatomy of the eye and the ear, but transduction is really important to understand. Okay. So Gestalt grouping. So remember, with Gestalt, our brains like to look at things with the whole picture in mind, right? They like to look at it in the whole rather than all the small pieces. When you're looking at, this slide and you're reading the text on the slide, you're not looking at all the individual letters. You're looking at it as a whole and making meaning out of what's on the slide, right? You're looking at the words and you're processing it and you're making meaning out of it. So you're looking at the whole picture rather than just all these parts that make it up. And it's just our brain's automatic, unconscious way to organize information in this afferent, remember, arrives at the brain sensory information. So afferent is where, it's the sensory where it arrives in the brain, and then efferent is it goes out. Remember that from the bio unit. So basically, Gestalt just means the whole. is more than the sum of its parts. And kind of, I just, reiterated my example is when you look at the slide, the meaning of these words is more important than just the individual letters. Okay, and then there's just on this slide, there's just, don't forget to maybe go back, look at the review guide that I gave you. You have to kind of know the differences with some of these. So this is just the way our brain organizes information that we're seeing. So, proximity, how closely things are together, similarity, our brain likes to group things, with things that are similar. The figure ground, that's always super important. So make sure to kind of go over that one again, where this one is just basically, our brains are wired to just process things and do things one thing at a time. Like our attention can go to one thing. So here is where it is the candle or the vase you're seeing, is that in your, figure, and the faces are in the ground, so the background? Or is it the faces are in your figure and the vase is in the background? So it's just like the way that your brain processes that information. It's nice to know continuity, closure, connectedness. It's just, those are ways the Gestalt principles group, the way that we process that information. Okay? All right, so depth perception, remember that's the ability to perceive objects three-dimensionally. And we do that using monocular cues, so one eye, versus binocular cues, like both eyes. So it might be helpful to go back through your notes just to look at some of these monocular cues, again, just one eye, and then the binocular cues, that depends on both eyes. Okay, and those are important, and those are all in that review guide on Schoology. Don't forget, print that out. That'll be helpful for you to have on the exam. Okay, I think that's all I wanted on that. Okay, and then remember the thresholds. So this is, again, I put transduction in here because it's, again, that process of turning environmental energy into like neural energy, actual potential, and then it goes to perception, and then it goes to thought. Okay, so then it's like what you think. Okay, so absolute threshold. Remember, that's the lowest level of stimulus that we can reliably notice 50% of the time. So I have, a watch. I have it connected to my phone, and it buzzes me when there's like a text or a Gmail message or something like that. So sometimes I just automatically think that it's buzzed, but then it hasn't. So that's reliably. So how often does it happen where it's reliable 50% of the time? Okay, just noticeable difference. That's where that stimulus is there, but how do we notice the change? Like we did that video, remember, in class, where the guy was in the car and he had his music and he turned it up, it was at 10, but he turned it to 11. Could you really notice a difference, or did it have to be at 15 or then 20 to then notice a difference? So it's just that noticeable difference. That's where the JND is. And again, like it could be with anything, with water. If you have lemon in your water, do you notice it, if it's a whole or a half? If there's salt in your water, how much do you notice a difference when things are added? Okay, the Weber's law comes into play because that makes that JND proportionate. So if I'm lifting 100 pounds, would I really know a difference if one more pound was added? Probably not. But if it was, 10 pounds or 5 pounds, I definitely would notice if it was, a lot more added. Okay, so it depends on proportion. Okay. And then the principles of sensory transduction. This is just that signal detection theory, kind of what I was referring to with my watch. Like if I thought that there was a message because I, felt my arm move and I looked and there was no message, that would be a false alarm, right? So it's our psychological reasons to detect. And that really is our motivation, our attention, and our ability to notice things. So that really comes into play with signal detection theory. Sensory adaptation, again, the brain can only pay attention to one thing at a time. So if you're working at Panera and you smell bread all the time, you might not really notice that after 20 minutes of being in the room because you're paying attention to something else, right? The same thing with, if I had my watch and I moved it to my right hand, I probably would notice it at first, but then the more that I get to do something and the more that my brain pays attention to something else, then I'm not even going to notice that my watch is on my right arm anymore. Do you know what I'm saying? And then sensory habituation. This is when you've heard something so much that you don't necessarily then react as much. And that happened. Remember, there was we saw like a little toy with a baby, and you're like putting this rattle in the baby's face. And at first, it's like, yay, this is so exciting to see. And then the more they see it, they're like, I'm done with it. They don't even react anymore to it. I sometimes do this with my alarm on my phone. Try to just get up and go, but I'm hitting snooze a lot more lately. And then, I don't even react to that sound anymore. So it's habituation. All right. Okay. And so now we're going to move into the anatomy of the eye, because this is a big part of the exam. So you not only have to know kind of like the structures of the eye, but you have to know like what in order of how light comes in the eye. Okay, so I want to make sure I get all this for you here. Okay, so the parts of the eye, so it starts with the cornea, and remember the cornea is just like that covering over your eye. So think of it kind of like that clear part that protects your eye, kind of like a windshield wiper, okay? And then it goes the iris, and that's that colorful muscle, okay? And it closes, and then it lets light in through the pupil, which is just that hole, okay? Right? And that's where light comes in. So cornea to the iris and then the pupil, okay? And then it's the lens, and the lens is that clear, flexible image, and it refracts the light, and then it turns that image, remember, upside down in the back of the eye, which is kind of weird, but you see it as like upright. And then, so it goes cornea, iris, pupil, lens, refracts the light to the back of the eye. And then that's where the retina is with the fovea. Okay, so the retina is kind of like, if you think of the retina as like the movie screen, you're not looking at the outer edges of when you watch a movie on the movie screen, you're looking at the center. So the center of the retina is that fovea. And remember, the fovea is where rods and cones are. It's in the center of the retina. And the rods, remember, are black and white or black and gray. And they're in the peripheral of our eyesight. And then the cones, again, they're in the center and they're colorful. Okay. Don't forget my mnemonic for that. I like rainbow sprinkles on my cones. I think that was what it was. Okay, and then, you have your ganglion, your bipolar cells first, your ganglion cells, then it goes down to the optic nerve here, and that's where that message leaves the eye and goes to the visual cortex in the brain. And then you would have a blind spot. Don't forget we have that blind spot over here where, you can't see in part of your peripheral there. Okay. All right, theories of vision. There's the trichromatic, the three. That basically says you have these three colored cones in the eyes and that it responds to light. And then that combination is how we see colors, okay? So the advantage there is it works for the eye really well. What else do I want to tell you about this? I think that's it. The opponent process, that's where you have these three pairs of cones, and it goes like red, green, blue, yellow, and black and white. And basically the theory says that when there's these certain neural circuits, they get excited and they can't process the opposite color, okay, because it's inhibited. So for instance, like when blue circuits are active, you can't simultaneously see the yellow circuits. But the advantage there is it works for the brain, and then it explains the after image, which that after image is what happens when one side of the pair is excited, and then when you look at something else, then that rebound, you see that rebound color. And that's with this. We did this in class. If you stare at this image of the flag for like 30 seconds, and then you look at this dot on a white page, you're going to see the after images from that. Okay, and again, it's just, the brain explaining how we sense and perceive all this data that we're coming across every day. Okay, so I'm going to leave you there. We're going to start tomorrow with the anatomy of the ear. Okay, I'm going to stop you right here. Tomorrow we're going to go into the anatomy of the ear and more perception stuff. There's a short FRQ to do, and then if you have questions, don't hesitate to reach out. Take care.